I got this feeling inside my bones. It goes electric wavy when I turn it on. Off from my city, off from my home. We're flying up, no ceiling when we in our zone.
Hi guys.
Hi.
Look what I got.
What's that?
Power bank.
Oh,
You know how much it is?
It's 30 ringgit?
20? I guess it's 50.
No. 70?
Yeah, that sounds much more reasonable. It's too expensive now for 70 ringgit. But that is usually the original price, right?
You're wrong. I bought it for 10 ringgit only.
What? 10 ringgit?
Yes, 10 ringgit only.
Seriously?
Yeah, I'm serious.
Where did you get it from? Yeah.
I bought it online.
Wait a minute. Are you sure it's EMC compatible first? It's okay lah, because at market you can get 70 ringgit, right? But this one is already cheap. You can save more, 10 ringgit, right?
Yes.
Fine. What do you think, Vincent?
I think it is very important to be EMC compatible. If not, your phone will be damaged.
Absolutely, I agree with you. So where did you buy it? Why you think it is compatible for you?
I don't know what is EMC compatible, what it is.
No, Shakir, EMC compatible is to ensure that your device can go along with the power bank, like the external gadget that you use. So in order to prevent any short circuit or open circuit or anything to occur to your gadget, like your phone, so your gadget must be compatible. If it's not compatible, it can cause a huge damage, and for 10 ringgit, your phone is worth more. It's going to be damaged and you have to pay a lot of cost to repair it.
You hear that?
Okay, can you tell me more about EMC itself?
Okay, let's go to the history of EMC.
In 1899, the Navy initiated the first shipboard test of the wireless telegraph. While the test was successful in many ways, the Navy was unable to operate two transmitters simultaneously. The reason for this problem was that the operating frequency and bandwidth of the early wireless telegraph was primarily determined by the size, shape, and construction of the antenna. Receiving antennas were always tuned to the same operating frequency as the transmitter antenna. However, the bandwidth was difficult to control. Therefore, when two transmitters were operating simultaneously, receivers detected the field from both of them to some extent, and the received signal was generally unintelligible. This early electromagnetic compatibility problem came to be referred to as radio frequency interference, or RF. In 1904, Theodore Roosevelt signed an executive order empowering the Department of Commerce to regulate all private radio stations and the Navy to regulate all government stations. Different types of radio transmitters were assigned different frequency allocations and often were only allowed to operate at certain times in order to reduce the potential of RFI. The Federal Communication Commission (FCC) was established in 1934 as an independent agency of the U.S. government. It was empowered to regulate U.S. interstate and foreign communication by radio, wire, and cable. FCC regulations and licensing requirements significantly reduced the number of radio frequency interference problems. In the 1940s, many new types of radio transmitters and receivers were developed for using during World War II. Radio signals were not only used for communication but also to locate ships and planes using radar and to jam enemy radio communications. Because of the immediate need, this equipment was hurriedly installed on ships and planes, resulting in severe EMC problems. In 1954, the first Army Research Foundation Conference on Radio Frequency Interference was held. This annual conference was sponsored by both government and industry. 3 years later, the Professional Group on Radio Frequency Interference was established as the new newest of several professional groups of the Institute of Radio Engineers. Today, this group is known as the Electromagnetic Compatibility Society of the Institute of Electrical and Electronic Engineers, IEEE. During the 1960s, electronic devices and systems became an increasingly important part of our society and were crucial to our national defense. A typical aircraft carrier, for example, employed 35 radio transmitters, 56 radio receivers, 5 radars, 7 navigational aid systems, and well over 100 antennas. During the Vietnam War, Navy ships were often forced to shut down critical systems in order to allow other systems to function. This alarming situation focused even more attention on the issue of electromagnetic compatibility. Outside the military, an increasing dependence on computers, satellites, telephones, radios, and television made potential susceptibility to electromagnetic phenomena a very serious concern. Meanwhile, the 1970s witnessed the development of the microprocessor and the proliferation of small, low-cost, low-power semiconductor devices. Circuits utilizing these devices were much more sensitive to weak electromagnetic fields than the older vacuum tube circuit. As a result, more attention was directed towards solving an increasing number of electromagnetic susceptibility problems that occurred with these circuits. In addition to traditional radiated electromagnetic susceptibility problems, RES, due to intentional and unintentional radio frequency transmitters, 3 classes of electromagnetic susceptibility problems gained prominence in the 70s. Firstly is electrostatic discharge, ESD. Second is the EMP or electromagnetic pulse. The third is power line transient susceptibility or PLT. There are 2 events in the 1980s had significant wide-ranging effects on the field of electromagnetic compatibility. The first event is the introduction and proliferation of low-priced personal computers and workstations. Meanwhile, the second event is the revisions to Part 15 of the FCC rules and regulations that place limits on the electromagnetic emission from computing devices. In the 1990s, the European Union adopted EMC regulation that went well beyond the FCC requirements. The European regulations limited unintentional emissions from appliances, medical equipment, and a wide variety of electronic devices that were exempt from the FCC requirements. In addition, the European Union established requirements for the electromagnetic immunity of these devices and defined procedures for testing the susceptibility of electronic systems to radiated electromagnetic fields, conducted power and signal liners, and electrostatic discharge. The impact of these regulations was overwhelming. At a time when the market for computers was growing exponentially, many of the latest, most advanced designs were being held back because they were unable to meet government EMC requirements. Companies formed EMC departments and advertised for EMC engineers. An entire industry emerged to supply shielding materials, ferrites, and filters to computer companies. EMC short courses, test labs, magazines, and consultants began appearing throughout the world. The international attention focused on EMC encouraged additional research, and significant progress was made toward the development of more comprehensive test procedures and meaningful standards.
Hi, I'm Jacinta, and I'll be talking on the importance of EMC testing. So there's 3 major importance of EMC testing. The first is protection of the electromagnetic spectrum. The second is safety, and the third is product performance or quality.
Going on to the protection of the electromagnetic spectrum, we can see that there are a finite amount of electromagnetic spectrum such as radio transmission, microwave communication, X-ray machines, and other products. And even electronic devices without transmitters emit electromagnetic radiation. So, without limits to the amount of unintended electromagnetic radiation, electromagnetic spectrum can be adversely affected, as well as frequency bands reserved for radio transmission can be compromised. As you can see here. Therefore, protection of this electromagnetic spectrum is an essential resource to ensure that the device continues to function properly in the future. Now, moving on to the second importance of EMC testing is due to safety purpose. So EMC performance matters as it can distinguish between life and death. Many medical, military, and industrial have incorporated safety critical applications, to ensure that safety is taken into measure. So, if the function of those products fail due to electromagnetic phenomena such as power supply surges, ESD, and radiated electric fields, it can cause adverse safety issues. I'm going to give you an example. Imagine there are 300 cell phones transmitting 7 watts of power on an aircraft to 36,000 feet above. So its rigorous EMC ensures that the electric system can withstand those electromagnetic environment. So safety is taken into consideration. Moving on to the third importance of EMC testing is product performance or quality. Therefore, it is essential to reduce poor EMC performance. And the function and performance of an electric product can be easily affected internally or externally. So, if internally, I'll give an example. If the internal power regulation is too noisy, it can adversely affect the sensitive analog measurement. And how it affects externally is, it affects product in a virtually unlimited number of ways, which is through data corruption, measurement accuracy, RF performance, and it can also cause frying ICs. So that's all from me.
So for today, I'm going to explain a little bit about the future of the EMC testing. So we're going to take a look of it. So the first one is the standardization of rules. There is a concerted effort to standardize EMC testing requirements across the world, led primarily by the IEC, which is the International Electrotechnical Commission. The IEC generates standards that can be transposed by the country into their local standards, and in theory, this standardizes the EMC requirements across all the regions that adopt IEC standards. In the UK, for instance, 85% of IEC standards are transposed to UK standards. So next is the expansion of test requirements. In some countries, such as US and Canada, currently only emissions testing is required. Whereas in Europe, both emissions and immunity testing are mandated. Over the past few years, countries such as Australia and New Zealand have followed Europe's model and necessitate immunity testing as well. The push from the test labs, government, and international standards all indicate that requirements for immunity testing is increasing. And lastly is the consolidation of EMC test labs. Recently announced new rules of EMC test labs by the FCC means that transmitter certification testing will only be accepted from recognized and accredited test labs. Approximately 2 over 3 of the 1,000 or so the test sites registered with the FCC are currently not accredited. The extra requirements are likely going to favor larger test labs, that can absorb the accreditation overhead cost and staffing and may force smaller test labs out of business.